Hello there, 11th graders. This is teacher Krishna, and welcome to our physics class for week number 16. Thank you a lot one more time for entering all of the online lessons that we have prepared for you, and as well for completing all of the assignments that you have had so far. Keep up the hard work, please. And just like always, before we start, log into Agilex, enter the Google Classroom, download your Word document, and save it inside your physics folder. And of course, you have to name it just as it is specified right there. Notice that I will be checking the summaries very soon, so make sure that you follow the examples that I have shared with you and that you have everything in order so far. And as we move, remember to take notes on your Word document, so that will help you out to keep track of the most essential things from here. It is always necessary to start with our end in mind, so for topic 6.03, the end in mind is the following. Describe the properties and characteristics of waves to apply their knowledge in realistic studies of the appearing waves in Earth. Alright, so make sure to keep track of this very important information in your Word document. And this week we're going to study several wave problems. We're going to study some general concepts, we're going to study about some real applications that we can have around us, and of course some exercises and formulas, which is basically what physics is all about. Okay, so it's important that you remember some important terms such as wavelength, frequency, and the period. Remembering that wavelength is basically the distance from one of the crests to another in a wave. The frequency is how many waves you have in a certain period of time. And the period is like how fast a wave is moving. Okay, we have something very important, which is reflection. And just like it says right here, when electromagnetic waves hit a mirror, they will be redirected, and the angle of the incident and the angle of the reflection are the same. I am wondering if you ever had one of those lasers that you can find in the fair. They are very popular here, and if you have ever pointed that laser to one mirror, you will notice that another like light or another red spot will appear in a different direction. So this is exactly what happens with the waves. So when they hit a mirror, then the light is going to be reflected in the same angle where it is coming from. I will show you a picture later on so you can have a better idea of it. And besides reflection, we have something that is called refraction. And the waves go through two mediums, water and air. The change of the image that we perceive is known as refraction. It also has an angle of incident and an angle of reflection. So, in the example that I gave you before about a laser that will hit the mirror and then it will be redirected, then we can analyze that basically the light is just going through one medium, which will be air. And thanks to the properties of the mirror, it will be reflected in the same direction. But what happens in refraction is that light can go through two different mediums, such as air and water. And the behavior of how light acts upon air and how it acts upon water is different. So the angle that you get later on is not the same. Just like it says right there, the angle of reflection will be smaller if the light waves move slower in the second medium. Here you have an example of what reflection looks like. Just the example that I gave you about laser will represent what is right here. So the red arrow is basically the laser that you can point towards a mirror. And you can notice that there is an angle of incident and an angle of reflection. So they are both the same because of the properties we're analyzing. But here we have a very interesting image about a pencil inside a cup of water. And you can notice that, of course, it looks like if the pencil had been teared apart or as if there was something weird in there. So this is basically the principle of refraction at its best, because the behavior of the light in air and the behavior of the light in water is different. And because of the change in angle that you get in both of them, then you get this change in the image. Okay, that's just for you to take it into account. Now let's go with refraction and speed. And we can analyze sound as it travels through different mediums, from air to water. And it will speed up or slow down as it goes from one medium to another. It is important to remember that there are different kinds of waves around. Light is one of the waves we analyzed last time, but we can also analyze the waves that are produced by sound. And when waves have a certain speed, they are going to be modifying the mediums where they are acting on. Like the example that we have here, the sound can travel from air to water, but when it enters water, then its speed will be affected because it is changing from one medium to another. And some waves may refract as it moves from medium A to medium B. And so right now I have a small exercise for you in order for you to explore a little bit more about what I'm talking about. So please go to page 1 of the topic and expand your knowledge by exploring the sections Try This and Combination. So in Try This, they are going to give you an experiment that I will like you to do. It is something very simple that you can do with some simple materials at home, and that will help you understand a little bit better about how all of this topic about reflection and refraction works. Okay, and on the right we have an image that represents how the waves are acting upon different mediums. So you can notice that we have the arrow, the black arrow in there, and in medium 1 it has a certain direction, but when it enters medium B it changes its direction. Okay. It happens basically because the waves are going to act differently depending on what medium they are on. Just like here, it will be air and then water. Now we're going to talk a little bit about wave behavior. We have diffraction, the bending of waves around an obstacle. And what sound can you listen around you? So, diffraction explains that even though the sound is produced in a certain spot, it can be, or it can happen that waves travel around the medium that is, of course, around the object that is producing the sound. And when they start traveling, then you're going to get a different perception, even if you're close or if you are far from the object that is producing the sound. For example, let's suppose that someone is talking right around the corner. So it is possible for you to listen to him or to her voice because of the principle of the diffraction. The person is producing the sound, and even though the person is not directly talking to you, it is affecting the medium, which will be air, basically, that is around the person. And diffraction basically is the expansion of the waves in the medium. We also have interference, and when two similar waves travel through the same medium. So let's go back to the example that I gave you about someone talking around the corner. And let's imagine that now two people are talking at the same time. So what happens is that the sounds of their voices are going to be mixed up. So it will be harder for you to understand what they are saying. And that is basically interference. So people or other waves are being acting in the same way and in the same medium. So it is more difficult to identify what is happening. And we have some other examples right here. So two crests or troughs with the same amplitude. So basically what happens in there when these waves encounter each other, a wave with double the original amplitude is created. So when you have similar waves with the same crest and the same trough, they are going to be added up, and they are going to create a way bigger wave than it was originally. That is known as constructive interference. Then we have another important term or situation, which is when one crest and one trough with the same amplitude are affecting each other. So remember that a crest is the maximum height that a wave can achieve at the top. And the trough is the lowest part of the wave. So basically, we're analyzing this one. The crest is at the top and the trough is at the bottom. So when they interact within each other and they are pretty similar, they are going to create a wave with a zero amplitude. And we know this phenomenon as destructive interference. All right, and here we have an example of diffraction. Just like I was telling you, the waves are going to start acting differently and expanding around the medium. So from left to right, you can notice that the waves are smaller and then they are bigger because of the same principle of diffraction. And here we have examples of the interference. And if we analyze example on the left, you can notice that the waves add up to create a bigger wave. And if we analyze the example from the right, you can notice that they are like opposite waves. So while someone is acting at the top, the other one is acting at the bottom. So when they mix up, they have a decrease in amplitude. And of course, they create a smaller wave. Okay, and now we're going to go to explore the Doppler effect. So go to page 2 and go over the explanation for what the Doppler effect is. And complete the simulation to find out about how precisely it works. So it's your time to explore a little bit about the Doppler effect in page number 2. And I'm pretty sure that you will find this picture very helpful. So just to give you a small introduction. So basically, there is an ambulance that is going to go by, and that at some point is going to be far away from you, and at another point it is going to come closer to you. And let's imagine that this ambulance has its siren on. So imagine when the ambulance is far away from you, then you are going to listen that the sound that the siren is producing is very low. But once it comes closer to you, then you will notice that the sound, of course, will be higher than before. So the Doppler effect will explain you why that happens, of course, from your perspective. So go to page 2, go ahead, read all of the information right there and go through the simulation so you can understand why this happens in this way. All right, now we're going to go with some wave calculations. So I copied this directly from Agilex because there are some symbols that cannot be exactly represented right here in PowerPoint. So we have that the equations for the speed of a wave are, remember v can stand for velocity or speed, will equal the wavelength times the frequency, and the velocity will equal distance divided by time. So something very important that you need to notice are the terms and also the units. So I recommend that you have a specific compilation of these two formulas and of course what they stand for, and of course the units, because that is something pretty helpful that is going to allow you to complete successfully the problems that you will encounter later on. So letter V will stand for the wave speed in meters per second. We also have F, which is the frequency in waves divided by seconds. We have this symbol that reminds us of a letter A, or a triangle is the wavelength in meters. We have D is the linear distance, and T is the time. One more time, keep track of this important information on your Word document So you can solve the problems easily later on. And now we're going to jump to some exercises to exemplify how we're going to use the formulas from before. So here we have, if a water wave vibrates up and down 2 times each second, and the distance between wave crests is 1.5 meters, what is the frequency of the wave? Okay, so something very, very important is to analyze the term frequency. What is it exactly? So remember that we were analyzing that the frequency of a wave is like the amount of oscillations that it will have during a certain time. And just like it is exemplifying it here, it says that the waves vibrate up and down 2 times each second. Okay, so what is the frequency? Obviously, it will be 2 waves per second. Sometimes it's a little bit difficult to find out about the values, but it will be definitely easier if you have a good concept in your mind about each one of the key terms that we have studied before. We also have, what is the wavelength? Remember, the wavelength is the distance in between crests. Okay? So it says that the distance between crests, a wave, is at 1.5 meters. Something very, very simple. And lastly, what is the wave speed? So something that is very important is that you have to list the givens from the problem. What information do you have that will help you out to find about what they're asking for? So the givens that we have are first our wavelength, which is 1.5 meters, and our frequency, which will be 2 waves per second. All right, so what is the formula for speed? The formula for speed is specified right below. So speed will equal the wavelength times the frequency. And now we just substitute the values. We have that the wavelength is 1.5 meters and that the frequency is 2 waves per second. So what will be the speed of the wave? It will be 3.0 meters per second. Now, something that is very important in here is that we are not going to take into account waves inside the units that we are going to specify in the speed. All right, so and it really helps you out to understand the concept of frequency, but once you operate it, we do not take waves into account. So that is why the result is just meters per second. All right, and now let's go with another exercise. This one is a little bit longer, but let's go over it. So, in diagnostic ultrasound, a sound wave with frequencies beyond our sonic spectrum is sent through the tissue. Sound waves are sent through the tissue by a transponder. When the sound wave encounters a boundary where its speed changes, part of the sound wave is reflected and detected by the transducer, which send the wave. These reflected waves are used to draw a picture of the object that is reflecting the sound wave. So this is just a little introduction before the problems that we have to analyze. And a metal fragment is in a patient. The speed of sound in the tissue is 1450 meters per second. The depth of the fragment is 0.265 meters. What will be the time between the transducer emitting the sound and picking the sound echo up? So here I have the process. So in order to find out about the time, we will have to divide the distance by our speed or our velocity. So if we substitute the values that we have that the distance is 0.265 meters, and we have that our speed is 1450 meters per second. So after we complete the division, we will find out that our time equals 0.000183 seconds. So that is something that is extremely fast. And of course, we have to take into consideration that we are talking about waves. And of course, waves are always moving extremely fast. Now let's go with the other problem. The smallest object that can be resolved with a given ultrasound frequency in a diagram scanner depends on the wavelength of that ultrasound. If 20 is 6, this will be waves per second. Ultrasound is used for a scan of the eye, and the speed of sound in the tissue is 1500 meters per second. What is the smallest detail observable? So this might be a little bit tricky. They're talking about the smallest detail. In other words, we're talking about the wavelength. So our wavelength will be velocity divided by the frequency. And if we substitute the values, we have that our speed or velocity is 1500 meters per second divided by 27 waves per second. Okay? So once we substitute of that, we have that our wavelength will be 7.5 e minus 5 meters. All right. So these exercises are very simple. You only need to clearly analyze the information that you have in the text, and of course find out about what they're asking you to do. Okay, now let's go with an exercise. It is your turn. Now to complete some exercises, go to topic 6.03, page number 4, and complete all of the exercises that you find in there. That is going to help you out to exercise and understand a little bit more all of the concepts that we have studied. And of course, that will help you out to complete the evaluation that you will have for today. And the evaluation is read and summarize topic 6.03. Complete the assessment for topic 6.03. And then students have to upload just one Word document with summaries they have done during the unit to the Google Classroom. So all the summaries must be in order. So today I will open a specific part in Google Classroom so you can upload one Word document only with all of the summaries that you have done so far. Okay, so basically it's just copy and pasting the work that you have previously done. So I can check the notes that you have taken so far. And what is the rubric that I will use to evaluate your summaries? Order will be 1 point, complete content 1 point, general appearance 1 point, grammar 1 point, and images 1 point. So that is it for today's class, guys. Thank you for coming, and I will be seeing you around. Good luck with the evaluation and good luck with your summaries today. Goodbye.